Namaskar, this is Nayan and I welcome all of you to my new lecture series. Students, in my previous two videos, I solved a total of 10 problems from SLET 2024 Physical Science paper. Today also, I will continue this journey by solving another set of 5 problems. So, without further delay, let's get started. Problem number 11. This problem number 11 is asked from statistical mechanics topic, and according to this problem, for a photon gas, the distribution function is given by option A, e to the power minus epsilon by kt, option B, e to the power epsilon by kt plus 1, option C, 1 by e to the power epsilon by kt plus 1, option D, 1 by e to the power epsilon by kt minus 1. Here the correct answer is option D. Now let me show you how option D is the correct answer. Solution. We know photons are bosons and they obey Bose-Einstein statistics. So therefore, Bose-Einstein distribution function for bosons is given by f of epsilon is equal to 1 by e to the power alpha plus beta epsilon minus 1. But for photon gas or photons, alpha equal to 0 and beta equal to 1 by kt. Now let us substitute alpha equal to 0 and beta equal to kt in equation number 1. So after substituting alpha equal to 0 and beta equal to 1 by kt in equation number 1, we will get the distribution function as f of epsilon is equal to 1 by e to the power epsilon by kt minus 1. So therefore, the correct answer is option D. Okay. Next, problem number 12. This problem number 12 is asked from kinetic theory of gases topic, and according to this problem, two containers are filled with diatomic hydrogen gas and diatomic oxygen gas. The gases have the same temperature. Compare the average speed of hydrogen molecules to the average speed of oxygen molecules. Option A 1 by 16, option B 1 by 4, option C 16 by 1, option D 4 by 1. Here the correct answer is option D. Now let me show you how option D is the correct answer. Solution. We know according to kinetic theory of gases, the average speed of molecules is given by V average is equal to root over 8 kt divided by pi m. Here k is the Boltzmann's constant, T is the absolute temperature and m is the mass of one molecule. Here we have seen that when T is constant, then V average is directly proportional to 1 by root over m. First let me write this point. At constant temperature, V average is directly proportional to 1 by root over m. So here m is the mass of one molecule. Now let us find out the mass of one hydrogen molecule and mass of one oxygen molecule separately. So mass of oxygen molecule is given by 32 divided by Avogadro's number 6.6 6.023 into 10 to the power 23 gram. In terms of kilogram, mass of one oxygen molecule will be 32 divided by 6.023 into 10 to the power 26 kg. Next, let us find out the mass of one hydrogen molecule. The mass of one hydrogen molecule will be 2 divided by Avogadro's number 6.023 into 10 to the power 23 gram. In terms of kg, the mass of one hydrogen molecule will be 2 divided by 6.023 into 10 to the power 26 kg. Finally, let us find out the ratio of average speed of hydrogen molecules to the average speed of oxygen molecules. So, therefore, V average of hydrogen molecule divided by V average of oxygen molecules, which is equal to root over mass of oxygen molecule divided by mass of hydrogen molecule. If we divide this term by this term, we will get root over 32 divided by 2. So, after simplification, we will get root over 16 by 1, which is equal to 4 by 1. So, therefore, the correct answer is option D. Okay? Next, problem number 13. This problem number 13 is asked from thermodynamics topic, and according to this problem, the combined form of first and second law of thermodynamics is option A, T ds equal to du plus P dV. Option B, T ds equal to du minus P dV. Option C, du equal to T ds plus dq. Option D, dq equal to T ds plus P dV. Here the correct answer is option A. First, let me show you how option A is the correct answer. Solution. We know the mathematical form of first law of thermodynamics is given by delta Q is equal to du plus delta W. That means when a certain amount of heat is supplied to a system, then some amount of heat is used to increase in internal energy of the system, and the remaining heat is used to do the work. In case of gas expansion, the work done by the system is given by P dV, and according to second law of thermodynamics, delta Q is equal to T ds. First, let me write these points. Suppose this is equation number 1. In gas expansion, the work done by the system is given by delta W equal to P dV, and according to second law of thermodynamics, delta Q is equal to T ds. Next, let us substitute these values in equation number 1. So, after substituting these values in equation number 1, we will get T ds is equal to du plus P dV. So, we have seen that the combined form of first and second law of thermodynamics is T ds equal to du plus P dV. So option A is the correct answer. Okay. Next, problem number 14. This problem number 14 is asked from electronic communication systems topic, and according to this problem, in television broadcasting, which of the following modulation techniques are used for picture and sound? Option A, phase modulation and amplitude modulation. Option B, frequency modulation and phase modulation. Option C, amplitude modulation and frequency modulation. Option D, amplitude modulation. Here the correct answer is option C. Always remember, in television broadcasting, for transmitting a picture we always use amplitude modulation technique, and for transmitting an audio or sound we always use frequency modulation technique. First let me write this point. For picture we use amplitude modulation technique. For audio or sound we use frequency modulation technique. Note: in phase modulation, the signal quality degraded under noisy conditions. So this technique is not used in television broadcasting for picture and sound. So therefore the correct answer is option C. Next, problem number 15. This problem number 15 is also asked from electronic communication systems topic, and according to this problem, an amplitude modulated signal with 100% modulation will have a ratio of total sideband power to the carrier power equal to option A 1:2, option B 1:4, option C 2:3, option D 1:3. Students, to solve this problem, first let me define two important terms. First one is carrier power and second one is sideband power. Students, the power in the unmodulated carrier wave is known as the carrier power, and the power contained in upper and lower sidebands is known as the sideband power. First let me write these definitions. Carrier power, it is denoted by Pc. The power in the unmodulated carrier wave is known as the carrier power. Next, sideband power, it is denoted by Psb. The power contained in the upper and the lower sidebands is known as the sideband power. and the mathematical expression for sideband power is given by m square divided by 2 into carrier power. Here m is known as the modulation index. Modulation index. For 100% modulation, the value of modulation index is 1. For 100% modulation. ठीक है? Next, let us find out the ratio of sideband power to the carrier power. So therefore, PSB divided by PC is equal to sideband power is m square by 2 into carrier power divided by carrier power, which is equal to m square divided by 2. So in our case, the value of m is 1. So ultimately we will get 1 divided by 2. So the correct answer is option A. This can be written as 1:2. So option A is the correct answer. So this is all about today's video, and I hope that you have learned a lot from this video.